Okay, hey, train your plants every day. Jordan Scoville coming at you from the STEM lab this morning. Kind of working on a new project, one I've been kicking around for a little while now. Um, One I want to get done so I can gauge my Mason's tags. Again, I have cumulatively 4 or 5 years already, probably somewhere around 10,000 hours worth of stonework under my belt, across the board. But for me, it's one of those games that, you start over to a certain degree. A lot of that experience helps make the timelines that you spend in a new place or at a place that you're at looking for master tags. And this is not something that's a common idea or a given structure in a place. I just look at this personally. To master any craft, it's 10,000 hours, or at least that's the general rule. You want to be a good at guitar, you want to master guitar, it's 10,000 hours. Well, in a shop or something like that, whatever your craft may be, mechanics, woodworking, the physical kind of block that kind of generalizes it for everybody is about 10,000 hours, and that takes about 5 years. So if you want master tags, obviously it's going to take you about 5 years. Now you're going to train people in that time period. You're going to do every kind of task that's asked of you to do. Maybe not every task, but pretty close to it. And you should have a second nature to how operations and setups are going to go along that way. What's coming to you, what's going out. Is this a single person process? Is it a team of dynamic operation you're working on right now? Many different things along those lines. That's something you'll get. Probably a lot of it's going to be in the first couple of years when it's all hard and dirty, and over the consecutive years, it's going to be that process, repetitive, with variances on each individual process. And for stonemasonry in the mills, it's even more so, because of things like the shape of the rock that you're bringing in and how it's cut up, different lengths and operations, your original floor setup, multiple orders on the floor at once, crew that you might be bringing in, or how you have to work with a certain operation, and things along those manners. Remember, this is a STEM, science, technology, engineering process that I'm building for this, and it works great for a resume base. What are resume points that can be algebraically A equaled, management and safety scales. All those things are going to be correlated to whatever feature you add to A1 is really B when you look at it in a new industry or a new process or setups on the floor and things like that. It's going to be all the same process. It's all going to be the same space you're working in, but it's going to augment and change slightly, sometimes radically, depending on those setups. To what that thing. It's a science. This is the technology of taking those grid states, those forms, those processes, and engineering them to a mathematical base. And what that really looks like is essentially what I've started here is I'm going to do a handwritten, just because I like the challenge of it like that. I think it really implements something. If you can do a handwritten, then there's no reason you can't do it with a computer. It should be a hell of a lot faster. Drawing stuff out with a computer, it's just something I like to do. To scale, just take it to that whole nother level is what I like to do. But this is going to be a trainer's manifesto, a stonemason's manifesto, Italian gantry, operator's manual, floor works, things like that. I haven't really settled on what the name is going to be yet because of how many different processes are involved. It's going to cover everything from the basis of this is the full setup, this is kind of where your feet stand. There's multiple sets that are like that. Some have subtle differences, but you should be able to build what you need off of it. So right there I got scale, I got the size of the table, it's a 12 by 6 table, the scale of the gantry itself, the scale of the saw, the scale of the dumpster, the scale of the ditch, the scale of the bay. It's roughly I think a 55 by 24 between ditches and all the way back to the wall. I mapped a little bit of this out. I scaled all the sizes of the what's the arbor size of it. It's a 6 by 5 on size of that. So generally I can work off of those numbers. So it's real close to being the right shape and the right sizes. Because that's going to be really important while you're working your floor works and things like that. How do you make determinations to what's going to fit on your saw, how you got to do certain things, processes, and what have you. So we're going to get into a lot of the computer works. I took pictures of the computer that I'm doing, that I work. Things like multiple cuts, single cuts, smoothing. If it gets to it later in the processes, coping cuts, things where you need to get into the W function of the XYZ model of it for angling the saw and things like that, where you actually pick a degree and you fix that. How do you lock your table out? What's the process? Is there a specific floor setup that you need that is conducive? How to work things on and off the table correctly so you're not chipping edges, or in case there was a problem with the right side of your saw for some reason and the teeth ground off the day, that you need to be farther over. How do you set that stuff up? How do you angle stuff with wedges so that way you can use, really, really heavy rock that you have to use the forklift for, or your wrecking bar, pull it out, put it on the table, and push down the rest of the way, things like those kind of processes, so you don't chip edges, so you don't, beat up the product, how you don't beat up the table, things like that are really important. We're going to get into working pattern, how to work rerun, how to measure out the size of pre-measure your stuff so that way you know how it has to be cut. If you have to pull material off to then put it back on the table to make your first cut and then finish that cut off for pattern or treads. Let's say you're making 3 12s and there's enough for it and they're 4 foot and you got 5-6 foot of rock. You want to nip off the length first, pull that end off, finish your cut, put that back to the table, and finish that last cut in multiple stacks in many cases. How to keep everything square and lined up. How to mitigate, how to work a process. A lot of this stuff seems really simple, but it's easy to make mistakes. When you got rind edges or a brown edge, how do you check that? How do you read a rock to say, I'm going to do extra cuts here and cut one back so that way I can get a full yield? How to take single stacks or multiple stacks that are pretty burnt and lay them on the table so that way you know that you're going to get the proper hits that you're going to do without hitting edges or losing rocks or wasting time in cuts. There are certain things that can't be done in here per se. Obviously color isn't something I'm going to be able to integrate without some level of technology involved. Pictures, or when you get into color is a big one. What is brown? What are the spectrums of brown? What are the spectrums of green? When and where to integrate certain models. What is top bed, bottom bed? All those things can make a big difference for certain orders. Sometimes it's just blue thermal pattern or blue thermal treads and it doesn't matter. Some days that's stock order. How to read the cues on a order sheet. What are they looking for? Is this a rock face job? What do you got to do for that? How to idiot proof a cut. Let's say you're programming negative and for some reason you hit positive instead of programming in the negative first, or it didn't register when you went. It'll make that first cut, but the saw will move in the wrong direction because usually you're running it off the edge. Or there was junk, so it really wouldn't matter there. How do you correct that problem without wasting time or rock? Couple of different ways to do it. Tape measuring it, after you fix it, some certain things, and running it as a single cut or a multiple cut with 0 numbers of passes that will finish the model. Reading the computer screen, how to register. This is where you are with it, to zero it out, to then reset your programs. How to run tread block on the table, how to head off tread block, how to change blades. All of that stuff is fairly simple when you think about the STEM mechanics of making manuals for it, or what a resume would look like. It's just a really thick resume. There are other things that I want to talk about in my manifesto for a trainer that are really useful that you're going to have to know, and a lot of them go into floor setup. Having a working palette for reburns and recuts if you're working treads or small numbers of things. Setting up recut pallets for pattern, because you're taking stacks into consideration. Where do you normally put that stuff? When is it time to start running that stuff in an order? What cues do you need to be aware of in a set if you're going to do those things? Where do you put it when it's done? Figuring out the scale of the entire shop. Where is inch stuff outside? Where is 2-inch stuff outside most commonly? Where is full color? Where's variegated? Where is pattern already cut? What do we do with the treads? So it's not just scale of this. Eventually I'm going to need a scale of the entire shop and the entire complex itself, because in order to run one of these saws correctly, efficiently, and you don't need to know all that stuff, but it really is going to make your life a lot easier. And to be able to have that right out the gate, so I don't have to walk out and show you something, just bring me over your manual when you have a question, and I can turn to a right page for you and be able to tell you it should be somewhere here, and if I remember correctly, it's going to be right there from where I'm standing, or where a manager is going to be at. You can walk up to them. So where's that stuff at? It should be right there. Keep them in the shop. Keep the other guys going. Saves 3 people from walking around, just making problems, just not doing what's efficient, and it's not, I'm not saying anything about wasting time or just, doing any of those things. It's just efficiency. A huge part of STEM mechanics is efficiency. Engineering a building, you do it efficiently. You're going to say time. I'm not going to use steel, or I'm not going to use, cardboard. I want to use steel because that's what's efficient. Then you get into dimensions of steel as a hot roll and cold roll, and gauges and hardness and all those other things that would make a variable difference, that when you look at it in a note breakdown, A, B, C, D, to just separate the definition thereof of steel or millworks, it gets very broken down into an A, X, B, Y, C, Z system, which is a STEM problem. And basically they look like notes at the end of the day, or scaled principles and dimensions. Linearly, a definition or a writing of a system is 3 dimensions, which you visualize in your mind as essentially points. Letters are algebraic models of points in the system. And you have to correlate that in special relativity to what you do every day and consider that a observable universe. And we're closing off those borders there. It does get very complicated when you think about the dynamics of a thing, when you have to take in timelines and cost ratios and time for cuts or whatever the game may be, to, why I have to close something off as a general of relativity to say that's just this shop. Eventually you're going to learn those things. Eventually they'll put pressure or gravity on your system linearly, if that helps you understand. It's side pressures. It's not just gravity. This is the rock, it weighs this much, and that's why you need a forklift for it. But eventually, even with what I do, filling one of these is simple. Very simple. I have the challenge of making it fit and fit correctly. That's STEM. And practical as well. You want something that's going to be very useful as a trainer, as a manual for somebody to be able to say, it doesn't help me if they walk over to me after I've had this made. They need to just, I made the mistake. I gave them a basic tutorial. There's a proper key, so that way they know everything is in a language that is useful. So that's the challenge. Catch you on the next one.